And today we've got a little dangerous project together here. Today a little danger. Essentially we're going to take all this power of these lithium iron phosphate batteries, and we are going to make this into a battery pack using these battery separators and battery management board. So if you're interested in building something like this, I definitely want to say that you're doing it at your own risk. I'm not an expert at this. You do want to be very careful, to look at a lot of videos, do a lot of research before you do this, because essentially it can be pretty dangerous. There's a lot of power in these. This particular one is a little better battery chemistry, but you definitely want to be careful. So stay tuned if you want to find out more.
According to Wikipedia, the lithium iron phosphate battery, or LFP battery, is a type of lithium-ion battery using lithium iron phosphate as the cathode material and a graphitic carbon electrode with a metallic backing as the anode.
And that is the technical information on these batteries. They are actually, I think, a better chemistry than lithium ion polymers. They're not as volatile. If they're punctured, this is going to be a robot, so the chances of them falling are going to be up there. So if one of these is punctured, it's not a good day for sure, because it's going to start heating up and spewing all sorts of noxious gases. But they don't generally catch on fire like the other lithium batteries. So that's essentially why we're going to be using these today. And we're going to use these to separate those. So we're going to get into working on these now. Let's get them all into their cases. Okay, we've got the top part of the battery separators in, and it looks pretty good upon first look, but then I notice, what's going on with this guy? Why is he down a little bit lower? And then I happened to look at the batteries. I did get them, and there goes another one to kind of show you what happened. Look at these guys here. Slightly different safety ring around them. These guys are in there pretty tight. But when I got these, I did get some of them on the first batch. I got about 6 of them actually that had a little different color on the safety mask on the top positive part. Didn't really think much of it. I thought, okay, minor variation between batches, no big deal. But now that I get this packed together, I realize that all of those guys, and you'll see in a moment, I'll turn this over and you'll see that one on the bottom is in fact one of those items here. And as you see here, these have too much play, they can go in and out. Now, could I maybe bend something over as I solder them together? Yeah, I suppose I could. But then I'm always going to have these guys with the ability to move up and down. I mean, there's some leeway where I could press this down farther, but obviously, look, this one's not moving at all. These ones for the newer batches are in there nice and solid. There's probably a little more room I could press down on that one, but they're not moving. That's pretty much it. These definitely have a little difference in the actual length. So I'm going to have to order 6 new ones. I'm not going to waste those guys. I'll just make them into one pack for some other purpose. I'll have plenty of battery needs. So I'm planning on having multiple battery packs in different sections. But yeah, these ones here that have this fluctuation, they need to be taken out and replaced. so I don't have this happening all the time. You don't want that kind of vibration and movement in your battery pack. It's going to be sealed up, so I'm not going to be able to get access to it. So to be better safe than sorry, I'm going to order 6 new ones. The last batch I got was all the white tabs, so probably pretty secure in getting the latest batch that they have. And we'll fix that. So I'm going to have to wait until I get those new batteries. At the point now where I have my cheap little Amazon, it's actually nicely well constructed, but maybe not the most powerful spot welder. Bought it for about 48 bucks, I think, on eBay. I've got it up to its max setting because as I did a few little tests, I did this one on nickel and it went right through it on number 5. But what I'm using here is this nickel plated, tin or steel for this battery pack. So I started with this one here. After a little testing, the highest rating is what works best on this. It's flashing with, I think, 5 little pulses. So I'm going to go through, I'll do it in fast motion for you, slow motion for me, as I kind of put on the different items. I'm going to be marking up, this one's only got this one here so far. This will be the first cell, this will be the second set of cells, third set of cells, and the fourth cells. So I'm linking all these negatives together, all these positives together first, and then I'm going to run it from negative to positive through the bottom and then up, here, and then from here to down there. So it'll be all in a series. So that's it for the real time frame. I'm going to put you on speed motion so you can see me zip through this like nothing's nobody's business. So here we go. So this is only the top side, of course. I still got to do the bottom side. You notice these guys here, we have one I'm going to use for the connector for the negative, one for the positive. I hope these welds are pretty good. They feel okay. If I had gotten maybe a $60 or $70 spot welder, might have worked out a little better. But at this point now, these are going to be connected in series. So got the negative going essentially underneath. Negative comes positive, positive connects to this negative, comes up here to the positive, positive will come here to the negative, go down to the positive, and then positive to the negative, and then come out positive, and then that will be the positive terminal, and this will be our negative terminal of the entire battery. So I gotta kind of crisscross this electronically. The cells are connected on one side. I need to do the same thing for the other side, so I'm going to connect those cells, and then I have to start the series. That's where I need to be really careful to make sure I don't screw it up, because this is again 40 amps of massive power. So it's going to be a pretty big pack when it's done. I might just do a couple little more spot welds here. I'm going to put on the other cells on the other side, and then I'm going to do the dangerous part, and I'm going to probably use this I got this little thin nickel strip. Maybe use the setting a little lower, but this one seems to be more conductive. So I guess that's why most people, if you can get just straight nickel for your strips, then they go for that. But I wanted this structure, this larger structure, so I went for the nickel-plated steel. I mean, sometimes even say they're nickel, but they're really not. This is really nickel. And I'm going to connect it in series. Once I get the other cells on there, being very careful, but I'll just run strips across from that and weld into those. So that will hopefully make a nice connection between the cells where it needs to. So okay, so the next side is going to be a little easier because, yeah, well, I think it's going to be a little easier, but I'll kind of get into, connecting the various cells together, and see you back in a little bit. Sometimes when you purchase a decent product but not a very good product, and usually I like to purchase really good tools whenever I can, but I think this one is running out of juice. There's really no power indicator on here unless you plug it in. So I'm running across an issue here. If you'll see, it's not even making contact, and the welds don't really look that substantial. So something's going on here. It's still firing. Yeah, it doesn't seem to be sticking. See, it keeps making the popping sound like it's pulling away from the weld. So I'm gonna unplug this and turn it off and charge it, and maybe that is the issue as to why my welds are not being very strong. I wish this had some sort of indicator on it. I think it does when you plug it in, so I'll find out. Okay, so I got the power cord, and it says it will turn green. All right, okay. So yeah, you can only tell when the power indicator when it's charging. So yeah, I pretty much depleted my charge with just one side of the battery pack. So another 2 to 3 hours I'll have to recharge this up. But that's why these last connections were not really making good contact. So I'll have to go over those again. So waiting for the charge, and then I'll get back to it. So that's part of the project. And again, that's part of, I bought a good but featureless product. It's decent, it'll do the job, but it's just going to take you longer. If you got a lot of these to do, or you have a bigger pack than this, might be worth the extra $20, $30, maybe even $40 to get a really good unit. This one's not bad. It's made out of a nice aluminum case and everything. It appears to be doing the job. Maybe could look for a little more power, but yeah, there's no indicators, so you really don't know unless you start charging it if you're running low. So I may have to go over some of those other weld joints just to make sure I got a good connection. But well, another little issue with buying from a random seller, Chinese manufacturer selling on Amazon. One of the directions says that when it's fully charged, and you see these little indicator lights for low and then all the way up to high, it says the well, first it says the LED is going to be red. It's actually orange, and then it says when it's fully charged it's going to be green. So somebody made a decision to swap out that multicolored LED and just make them one colored, it looks like. So it appears to be fully charged. Again, another little flaw with this particular basic simple device, but I'm going to go ahead and unplug that, and we'll get started with some more welds. Okay, we've got all the backside connections. So this is her, cell bank 1. Now it's connected from the negative to the positive of bank number 2. Goes underneath, and there's no connection here, but we do have then this connection here for negatives is also connected to the positive. So that completes the underside. Still a little work to do on the front, on the top side. Okay, this is the part you really need to think about. So this is the top side. As I connected the cells before, as you saw. Now on the underside here, we have, of course, this is negative and positive, but underneath it, this is positive, that's negative. And these two banks are connected. So the power's going up here, down, and then up and down. Well, it's not quite going across that way though, because these two banks are connected on the other side. These two banks are also connected on the other side. So, right now, essentially, we don't have a connection between both sides. So, as you see on this side, we had cell 1 connected to cell 2, and then cell 2 connected to cell 3. But what we need to do on this side is to connect these two banks together, and that will complete our circuit, because we'll have the power going through here, and then with this new part here, it'll bridge down here and it go up here, and then this will be our positive out. So all we need to do is to connect these parts here, but this is the the scariest part, because you want to make sure you don't make a mistake. So just keep it going in series, and then I should be fine. So hope for the best. At this point, I think we have done all of our connections, so I'm going to see essentially if we have what we expect power-wise. So this is our negative, this is our positive. Okay, we've got 13.02. Alright, well, looks like we might need some charging of the pack, but that's approximately where I expected it would be. But okay, so that's not too bad. Let's just take it at different points. So this being our negative, this will go through here, and this will connect up. Okay, so that's at 6.5, so approximately 3.2 times 2. So that's about right. Let's go to our next level here. Okay, well that would be our positive. I think I'm going to go back here. 9.77. Okay, so that's about what we would want, and then we get here and we're at the 13.02. So yeah, looks like it is wired together. No fires, no explosions. So I would call that a success. Any day you don't burn down your house or your electronic shop, that's a good thing. So did choose the LifePO4 batteries because they're a little less dangerous in that respect. They definitely are going to have a bad day, but if you short them out, and this is a lot of power, but they don't normally catch on fire. They just start to smoke and push off toxic fumes. So lesser of the two evils. But looks like it's looking pretty good, and I'm going to get into the next level. We're going to need to put on our BMS for here, but at least this part is done. Okay. Notice I have a new desk, which is good because I didn't have much room before, but we've entered a new phase here for the battery pack. I decided that I wanted to have a sensor in each of the cells, so I could have an Arduino sketch that would indicate to me, the temperature of each of the different cells. Perhaps put in some logic that would alert me as to any issues. So I decided to use these 100K NTC thermistors with a great sketch, and I'm going to make another video about that separately, but just to suffice it to say, I needed to make a little sensor so I could stick it in between each of the different cells. Had to be thin, fairly reliable, and fast responsive, which these NTC thermistors are. It's hard to see, but it's just like a little glass bulb at the end of that with these leads coming off of it, and resistance decreases as temperature increases, so it allows you to compare voltages. And again, that'll be subject for another video, but I just needed something slim enough to slip in there that would it was kind of an afterthought, so I've already built the pack. I'm not gonna build some other system. These were fairly reliable, so that's what we're going to do today. I'm going to put a little bit of Kapton tape. I think that's the brand name. It's just basically a high temperature tape. Kind of stabilize them, keep them together, and that way I can just slip it inside between each of the different cell areas, and I'll know essentially what the temperatures are. So that's a little side project. You're going to see me sliding those in, so I just wanted to explain what those are all about. Sensors have been laid in. I did it in a crisscross pattern for a little better wire management. So one pointing this way, one that way, one that way, and one that way. So they're right on the top, so hopefully that will work. Use this Kapton tape for that. What we're going to be doing next is using this fish paper. I think they call it fish paper because normally it comes in a fashion that has kind of a scale design on it, just on one side, but I think this particular one, yeah, it's just flat. Just an insulating paper, and we're going to put that on top here. We're going to be using this HX4S F100A, which is for 100 amp. Essentially it's for 4 cells, so we're going to have the 1, 2, 3, 4 cells. It is going to be 12.8 volt minimum and 14.4 volt max. It's for 3.2 volt LifePO batteries specifically, so that's why I chose it. I've kind of figured out the wiring diagram. Comes with a little connector. We'll be wiring these into one into negative and then one into each of the different cells, so it'll be able to tell which bank of cells needs to get more juice. So we'll use this. It's hard to get fish paper in the back, but I'm going to lay some more fish paper on there, and we'll put this pretty much up here. Have to do some soldering and everything, and that's the plan. So here we go. And the wiring has been done. I didn't want to bore you with just all the soldering, little difficulties at times for that, but basically we've got our leads put in here for the positive lines. So on this particular unit, this balance protection circuit does come with these leads. The black goes to your negative, so I've got that hooked up there, and then each of the different leads will go to the first cell bank, second, third, and fourth. So I have those go to the positives of those as shown up here. So I went ahead and soldered all of those to the positive terminals for each of those. So going back here, I've also put on the C- line, which goes to the charger, and P- line, which goes to the load, the negative load, and then we have the positive line that just goes directly to the whole system. So yeah, the main parts of it is all wired in, negative into this B- section here. All those are soldered on as best as I can. I'm going to start taping this up, make this a little more organized if I can. and then we'll get into the finalization of getting this all into shrink wrap. So we're in the home stretch here. Voila, we have one wired up battery pack. Nothing's blowing up. That's a good sign. We've got our battery protection and balancing board here. We've got our sensor wires nice and neatly coming off the side here. Our positive lead coming off this side. Our negative leads to the charging unit and to the load from here. So I'm going to do one little last test just to make sure everything appears to be normal. I don't see any heat or anything. Doesn't look like we have any shortages. I did label the different cell banks just for posterity, since this is all going to be wrapped up and you're not going to see it, but just wanted to kind of identify for myself if I'm looking back for the video, if I need to look at any one of them, like, hey, the S2 banks of cells is having an issue. I'll have some visual as to what that entails, but everything's all taped up just to kind of keep it secure and in place, and it is ready for shrink wrap. Okay, picking the shrink wrap size was a little tricky. I ended up with this 235 millimeter shrink wrap. Got the traditional blue color for it. How I kind of tested it in the end, I actually bought like 3 rolls in total, but yeah, I should have. I had actually started at different sizes, so that's one of the reasons why I decided to expand it a bit. But what I did is I just cut off this little edge here to kind of see, you know, okay, where is that going to wrap around it. I think this should be, hopefully it's not too big, but I think it should shrink nicely around this, so we'll find out if 235 millimeters is going to work for this. And it's done. Shrink wrapping has made this final battery pack, protected it. We've got our battery balancing board in here. Everything's wired up. We've got our leads out here. I'll solder those so I have a little better connection to you know, charger and all. And we've got our sensor lines here. Everything's all set. The shrink wrap just kind of completed it. That size worked pretty good. In hindsight, it would have probably made it a little bit longer, so it overlapped here a bit, but that's okay. A little bit is to be expected. It is on a big long tube, but that size did work out well, and I think we're going to call that a wrap. So just check the voltage. Everything's exactly as it was before, 13.01 volts. So it's actually a good storage voltage, but I'll be charging it up just to make sure everything's working and the balancing is working. Probably should have done that before, but I think this will work out pretty well, and it's going to power my robot pretty well. So do thank you for watching the video. If you can, give me a thumbs up if you appreciated the video, if it helped you and kind of thinking about your own battery build. That's very helpful to us YouTubers and encourages us a lot. And of course, if you can subscribe, that would be awesome. We'll try to give you good content in the future and about all the different things we're doing towards our electronic projects and the things that we learn, such as all this. So thank you for watching, and I really appreciate it. Take care. Bye-bye.